Take a look at this. On the B, we're looking for experiment 2. So that means the only line that you're looking here is this one to the whole thing. Okay, so you have concentration A, concentration B, and your rate. Take a look at the question. What is this asking? It said the reaction go to completion under the condition on the experiment 2. What would be the final mole concentration of C? How much C am I gonna make? Take a look at equation up here. Think about your cooking days that we're talking about, how much you're doing. You need 1A, 2B to make 3C. Okay? Take a look at how many A you have. 0.24. Technically speaking, if you are thinking about this, if I have 0.24, then I'm going to have 3 times amount of C made. But you will see that I'm not going to choose this because A is my excess. That means A is extra because I only need 1 to make C. I only make 1 on A. Okay. On the other hand, B, I need 2 more of B to make C. But take a look at how much B I have. I only have 0.12. B is my limiting reagents, meaning B gonna run out first. If you guys are not sure, you can definitely use both. If you want to do that, you're welcome to do that. Meaning this, you can still do 0.24 mole of A. Now notice that you're not gonna get a very good answer because A is my excess. If you're taking a look at that, A is gonna make a lot more C than B is gonna make. Okay, and like we said, this is not the correct answer because I cannot make C if I do not have B anymore. B is gonna run out. Okay.
Yeah, always use.
Think about your cooking and you're making sandwiches, right? Like I said, you run out of bread, you have a lot of cheese, still doesn't matter. You can't make multiple sandwiches without bread. Or if you're making cheese sandwich, your cheese run out, same thing. Same scenario. Whichever run out first, that's gonna determine how much I'm gonna make. Make sense? Understand why we use B instead of A? Okay. Let's look at this one. I kind of get head start before you guys did. Pretty much, I make a new rate because I can't quite figure out what the other one is because there is nothing the same for the Y. So I try to make it the same for the Y. First, I look at the Y and I will notice when the X is the same, Y doubles, rate also doubles, so therefore Y is the first order. To make it clear, I'm going to make another one. So I use the first one to make a new line. So I make Y double. Yes.
Sorry. But like for X, since I didn't have like Y can cancel out, and I multiply so that Y can cancel out.
That's what I just did. So I choose this line to multiply by 2 so that I have a new line here, right? Since I multiplied this line by 2, I keep this the same though, X the same. Don't change the X because you don't know yet, but I know the rate is also double because we already figured out Y. Okay, based off of this, I now compare this one and the second one where my X double, but take a look at my rate. My rate doesn't change. So therefore X doesn't matter. So your rate law is basically K is equal to Y. Make sense? Yes? Okay, good. So that's what you're gonna have for this. Now, B said calculate the specific rate constant for the reaction specified in the unit. Again, same thing, you're just gonna plug in any line you want. So rate is, in this case, 7 times 10 to the negative 4 is equal to K time, notice I'm only picking up Y. Make sure you're only picking up Y, you're doing that. Okay? Now I'm gonna go and divide it by 0.1, which is the same thing, I multiply by 10. So K is equal to 7 times 10 to the negative 3 unit. 1 over seconds. Good. Right? Yes. And make sure you double check that is seconds. So yeah, this have to be 1 over second. All right. Number C is the one that where people kind of go like, wait, what? What happening? So let's take a look. Actually, the correct answer is between kind of more toward her though. But let's see. So let's see what happening. So we have this, right? Concentration, and they want to talk about Z. They said Z has to be 0.2 mole. Okay? So then you know this reaction. I'm going to write it. I'll write it here for this. I'm going to write it here for this. Okay, so C, I'm going to write it here. So we're going to say 2x plus y go to z. Okay, now we know we have z has to be from 0, go all the way to 0.2. I need to be making more z. Okay, my x initial concentration was 0.80. My y initial concentration was 0.60. Okay, based on the balanced equation, you know that if I have to do 0.2, right, I need to add 0.2 here. I'm gonna reduce by 0.2, so I'm gonna have this is 0.40. If I now this is reduced by time 2 actually, so it's gonna be 0.4 reduced, so it's just gonna be 0.40. Okay. Now, the way with this is this. If you're looking at this, that's what it is happen. Now talk about the rate. The question is doesn't want a concentration. The question want the rate. So which one in here, either x or y, which one affect the rate? Wait, yeah, rate is affected by y only, right? So therefore, I'm gonna look at y only, and we know that y in this case is what order? First order. Okay, you have the rate equation for that one. Remember what that equation looked like? First order looks something like this. ln of y time, right? Okay. I know sometime, somewhere, we got y across on that one. Not the right one. Wait. Never mind, never mind. It's fine. I am getting confused. Yeah, good idea. We're not going to have a lot of you guys on Monday, so test is on Tuesday. English test. So, anyway, so we get ln concentration of y to the t equal to negative k t plus ln concentration of y naught. Okay. We already have k calculated under the condition of this equation where the k is not changing. Right? Let's figure out how to put it in. So we're gonna say ln of y naught. We know that y naught in this case is starting with material, which is 0.6. Y after is 0.4. So we're gonna put both in. 0.40 negative kt, or actually I should plug in k2. K is 7 times 10 to the negative 3, negative kt, okay, plus ln of y naught is 0.6, okay. So I know my sentence is really bad. Let me just rewrite it for you guys. ln of 0.4 is equal to negative 7 times 10 to the negative 3 t plus ln of 0.6. Okay. I'm going to go and divide it. Subtract it. So ln of 0.4 minus ln of 0.6. Okay. If you do that, I can tell you, you're going to get a negative number. Right? But guess what? You're dividing by a negative number. So you do get a positive answer. Yeah? Right? ln of 0.4 minus ln of 0.6. Guys, girls, try to calculate this one because it's important that you can get this thing calculated correctly. So T would be equal to 57.9 seconds. Now, I can explain to you why that other one is problematic. Let me explain that one. Now, there is another one you guys might be thinking about because the rate can be solved by two different ways, technically speaking. Okay? So you see how we have this one, right? Yeah? Let's talk about another one. So, rate also could be affected by another one. You can also, you might be tempted to say rate is equal to K time, I mean not K time, sorry, change in concentration of Y over change in time. You also might be tempted to do this. Because after all, you kind of have the rate. Kind of. Negative, actually. This is negative. Or you can say change in concentration of Z over change in time. The reason why we didn't go through this route is this. You're looking for time. How long has it been go to? Time different. And you have rate, sort of. I want you guys to be careful when you use this one. In fact, the only time I'm going to say you guys use this one is when they ask for rate of appearing or rate of disappearing or certain thing. Here's a reason why I don't want you guys to use this. Because this rate is not equal to this rate right here. This rate is the initial rate of formation of Z. So when Z is coming up. After all, it's not even regular rate. It is actually more closely resemble this than actually this. I mean, more closely resemble this than this number. Now, if this have a coefficient, it's going to change on here. Now, another thing you should know is also this rate here is kind of more like over the certain time period or slope. And you guys know that the rate changes as the time change. Remember in the beginning, we calculated that this for over the time period, like 0 to 10 seconds versus 50 to 60 seconds, is not the same. Right? Example, let me see. Where's my graph? Example is in, I have too many papers, not the correct one. This one. Okay. Take a look at this one. And this one. Do you see how the rate changing? Talk about? So changing concentration over time is much more bigger value here than down here. Now it works if you have a zero order though. Your changing concentration over time is not changing, so therefore your rate remain consistent. Doesn't quite change it. The rate is equal to K. Okay, so we don't want to do that. And also, I think we also did calculation like that before. So anyway, so be very careful about using this. I wouldn't use this all the time. So check to see if there's another one. Ln 1 over those are better too. Let's talk about D. D is actually an interesting question. I'm going to break it down into each pieces. Okay. I'm going to write rate law for each one. So I'm not even going to look at the top one. I'm going to look at this to write rate law. Okay, number one is easy to write though. Take a look. You have a slow step. If you have a slow as a first step, those are really easy. You just look at it and you pick up the coefficients and you just write it. Right? So elementary step, you can just pick out and you can just write it. So this one is going to be, right, rate is equal to K, X, and then Y. Yeah? No, it's fine. You can write YX if you want. Okay. Now, this one, number 3 is also really easy because this is a slow first step. So that means rate is equal to K, Y. See how it goes? Slow step, fast step. Okay, let's talk about number 2. Yeah, this probably is your most not favorite one because your slow step happened after and your fast step has the intermediate. So we need to talk about it. So the rate is going to equal to K, Y, and then M. Again, the goal is to get rid of M. So then you're going to use the first line to write equation. So you're going to say rate is equal to K X squared. Okay, that's a forward. Okay, forward. Okay, reverse is gonna be equal to K. You can say K inverse if you want, basically M. Now I can equal these two together. So I can say Kx squared is equal to K inverse M. Pretty much saying M is equal to K times X squared. So I can plug in here so that I can say rate is equal to K Y instead of M, right, I am gonna plug in this into here. So you're gonna say X squared. K Y X squared. Now notice that I kind of solidify all the K as a K, doesn't matter. K is constant, so I'm not gonna change it. So you're gonna get rate is equal to, yeah? Make sense? So therefore, number D answer is 3. Yeah? Yeah, you got it. All right. All right. Got it? Question? All right.